Okay, and we are recording. Okay, welcome to Math 219. This recording is going to go over a bunch of ideas, facts, organizational minutia, and also broad stroke important advice for how to do well in the course. Various things that normally I would do on the first day of class, but there's just so many of these things to say, it just doesn't really fit well with the schedule of the course. So I like to do this these days in a recording. I'll get all this said without using our very limited and valuable class time. So again, welcome to Math 219. I'm Clark Bray. If you're seeing this, you're probably enrolled in my section of the course. Okay, so diving in here to the points we want to discuss very quickly. If you are a math major, I suggest that you consider coming and talking to me. No big deal. I just thought it'd be first of all, welcome you to the math major, to the math department, but also just to ask you some questions about classes you've taken, what classes you're planning to take next. Kind of think through whether you have everything on the right track. It'll be a very short conversation. Okay, good. Okay, so let's talk about the class website. The class website is located at this address right here. You can type that in. You probably, though, will have, by the time you're watching this, you will have already received an email from me in which I suspect I will have remembered to include the link in the email, so you can just click on that link. And we're going to talk through a bunch of stuff about that website in just a couple of seconds. I'll also point out, though, that there is also a there is a shared course website that applies to all sections of Math 219. Well, all of the sections other than Sections 6 and 7 this semester are doing an independent, slightly different curriculum, and so they're organized separately from us. But anyway, so all 5 of Sections 1 through 5 are organized through this shared course website. Okay, all right, so we're going to, again, talk through some of the most critical stuff, but very importantly, all of the information that's on both of these websites is all very important. So you need to make sure to read through all of it. Make sure you understand all of the important discussions and facts and organizational structure and all that kind of stuff. While you're there, I think it's also a good idea to click around on the various links to see what's where. You don't have to memorize, of course, everything that's on the website, but you do at least want to know where to go to find what information that you might need to refer to later. Okay. All right. So, so diving in from the website, I want to point out in particular the content syllabus. So let's go there. Here is the my sections, what I sometimes call my class website. You can see I use the word class to refer to things that apply just to my sections. I'll use the word course. I'll make every effort anyway to refer to things that have to do with Math 219 in general, or sometimes to the this semester's all offerings of Math 219, all sections. Okay, so let's go to the course website, clicking right here on this big bold link right there. This is the course website. You'll see that there aren't yet, but there will be links to all of the different instructors, different class or section websites, and mine is already there. Scrolling down just a little bit, you'll see I have a compact little set of links here, and you're also going to notice that the web design level of sophistication is extremely low. I wanted to make these web pages as efficient and to the point as possible, so they're very low maintenance websites, I'll say. Anyway, all right, so content syllabus right here. click on Content Syllabus. This shows everything concerning course content for this course. You see Spring 2024, Math 219. You see the textbook listing. By the way, I really like this textbook. This is an excellent book. No book is perfect. I have a couple of little quibbles, but by and large, it's an excellent book on the subject. I'm going to point you to this first cell right here that enumerates what I hope is obvious, that you're responsible for all the prerequisites, all the material in the textbook in the sections that we cover, and all the stuff in class. So again, hopefully obvious, but needs to be said. The prerequisite material, I make a reference here to the prerequisite trail, right? So the point is that everything in this course is prerequisite on previous course, which is, they have their own prerequisites, which have their own prerequisites, and you can trace this all the way back down to like algebra and geometry and stuff from high school. So all of that is prerequisite. It's part of the prerequisite trail. I do expect that you will be proficient with all the material in the prerequisite trail. If you are concerned, maybe not quite proficient, maybe have some gaps, you'd want to fill that in. Take a little bit of time and solidify, make sure that you're good to go with all of the prerequisite material. There are a couple of specific topics that I note just because I'm going to be using them specifically quite a bit in this course. And further, because they are topics that a surprising number of students are actually a little iffy on. And so specifically linear transformations and what they have to do with matrices, right? For every linear transformation, there's a corresponding matrix, blah, blah, blah. Make sure you're comfortable with all that. What I call standard geometric examples of linear transformations and how those examples are represented with matrices. Things like rotations in the plane, rotations in 3-space, reflections in the plane, etc. So you want to make sure that you are good to go with all that. We will say a few quick words about this in class, first day of class, but they're going to be quick. And I'm going to assume that you're good with all that stuff. If you're not, what you're going to want to do is come to my office hours and ask me, and I'll be very happy. If you have concerns about this sort of stuff, and what's the deal with linear transformations and matrices, or how does that apply to rotations, come on into office hours. Be very happy to talk you through it and make sure that everybody's solid on all that stuff. Okay. All right, moving along. So you'll see we have a bunch of topics listed here. There's this column on the far left indicating which book section. The next column indicating the title, which is kind of convenience of reference, title of the section. This next column indicates which of the exercises from that section will be assigned as homework. And how and when they are assigned as homework we'll get to when we get to the class schedule, and that'll be in just a couple of minutes. But anyway, these are, when we assign section 1.2, these are the exercises from section 1.2 that are part of that homework assignment. Okay. All righty. Note a couple of little comments are inserted. Not very many, but do pay attention to those. So Part D of number 28 in Section 1.6 makes a reference to proving something, and this absolves you of the need to prove the result. So anyway, again, pay attention to that kind of thing. Let's see here. AHP. This AHP is short for Additional Homework Problems. I have found in teaching this course through this book that there are a few categories of exercises that that weren't represented in the book, and I think it was sort of too bad. Stuff that I think should be assigned exercises. So when I need to supplement what I have to choose from in the textbook itself, I add an AHP, and you will find that AHP document on the course website in the resources section, or let's see, no, the course materials section, so when 1.6 is assigned, AHP 1, 2, 3, 4 are going to be part of that assignment and due with that homework. Okay. All right, a couple other columns I want to talk about, the included material and the excluded material. So very importantly, this course is not going to follow exactly the textbook. The textbook was not written, tailored specifically for this course. So there are some topics that are included in the textbook that are just not what we want to focus on in this course. As a broad stroke, I'll say I think the target level of the textbook is just a little higher than the target level for the course. And so there are going to be a few things here and there where, we just, we don't need to worry about. So this business about proving properties of cross products, we're not going to focus on that. So there is an addendum in the textbook in section 1.4. There's an addendum called Proofs of Cross-Product Properties, and you do not need to look at that. Now, you are welcome to look at that, and there are good ideas in that section. And if you are interested, if you want that extra practice, to check yourself and make sure you're understanding at the deepest possible level, by all means, absolutely feel free to go and look at that. But you're not responsible for it. Okay. Now, on the flip side, what I call here included material. So this is stuff where the book, rather than doing too much, there are topics where I feel like the book doesn't do really enough. So, for example, when we get to the chain rule, section 2.5, there is an application of how to use the chain rule to talk about second derivatives. And it's confusing and important. And so I feel like this is an important topic to be included in the course, and the book doesn't talk about it. So that's why I have this in the included material column. So this discussion is going to be in the lectures for the course, and it's in my lecture notes, and it is part of the course. You are responsible for it, even though it's not in the textbook. Okay, and so you'll notice there's a few more examples here and there. For whatever it's worth, do notice there's a lot more in the excluded material column than the included material. So all in all, I think these little edits are to the student's advantage. Okay, all right, so that's how the content syllabus works. And let's see now, going back to my organizational notes here, next thing to talk about is the class schedule. Okay, so the class schedule, note the word class, not course. So this is, we're going to go back now to, I'll click here where I have my name and my sections of the course. You can click right there. Here we are back at the class website. And the class schedule, here it is, second link. Right? So this is going to keep track of where we are and what we've done and what we're doing and what we're about to do throughout the semester. And I think this is very organized and detailed, and this should be an important tool for you to keep track of what's going on in the class. So various things to talk through. You'll see I have all the class meetings listed, Monday, Wednesday, Friday, of course, for my sections. And so for any given date in any given week, this target column indicates where in my lecture notes I expect to have finished. So you can see my goal, and this may be a little aggressive, but my goal on the first class meeting is to finish Chapter 1 through page 9 of my lecture notes. Now, again, that might be a little optimistic. We'll see what actually happens. By the way, it is very routinely the case that I'm behind schedule. We always catch up at the end. I've never not made it. But sometimes I am behind schedule for much of the term. I do front load the schedule, by the way, because there's so much material in this course. I find that it's extremely important that I always be moving as fast as I reasonably can. in order to get the material done. And being behind schedule, or at least appearing to be behind schedule, helps me. It helps light a fire under me and keep me going. And I would love to go on a digression and talk about something interesting but non-critical, and thus effectively make a bad decision time-wise. So being behind schedule helps me to stay on pace, frankly. Okay, so since I will probably not actually hit these targets, what actually happens in Section 1, Section 2, and Section 3 on any given date? For any given date, I will indicate in these corresponding cells what actually happened that day. And so that's how you can keep track of where we actually are. You'll notice it won't be the same in the 3 different sections. Every section has its own kind of personality and character, and there are some where I tend to move a little faster, some where I tend to move a little slower, but they're rarely very, very significantly different. Okay. Alrighty. Note, I have also in this section here, I have an indication of things, fixed events, like we have a holiday for MLK Junior Day. Also fixed, Exam 1 is on Friday, February 9th, et cetera, et cetera. Spring break, Exam 2, Exam 3, final. All of that's noted on the schedule here. And now let's talk about homework assignments. So homework assignments will not be exactly by the week. They'll be approximately by the week, but not exactly. Here is a typical homework. Let's look at homework number 2. You'll see that it ends, the last bit of material that's part of homework number 2 is not a Friday. The last bit of material for homework 2 is for a Wednesday. The idea here is I want the homeworks to be due at the end of the weekend. You'll see typically anyway, homeworks are due on Sundays. This one's due on a Sunday. That gives you the weekend to work things out, which I think is a good, efficient use of time. And that being said, if I were to include Friday material on a homework set due on Sunday, I just don't think that's reasonable, because then students don't have the opportunity to go and get help with office hours. So I think the last day for a given homework set should be typically on a Wednesday. And that is the case for most of the homework sets. There's some weird little glitches around exam days, but Wednesday tends to be the last day defining a homework set. That means that the first day tends to be a Friday. Okay, so typically speaking, all exceptions granted. How am I going to do this? I can't highlight it the way I wanted to, but typically Friday, Monday, Wednesday, whatever we cover on those 3 days will be part of a given homework assignment with a given due date, all indicated here on the schedule. Okay, I hope that all makes sense. By the way, homeworks are due at 11 p.m. Eastern Time on whatever the indicated date is. They'll be submitted through Gradescope. I presume y'all are all very familiar with Gradescope. Right. Okay, so real quick while we're here, I'm also going to point out there are a few exceptions to the Wednesday due date rough rule. In particular, look at homework 4, not due on Sunday, it's due on Friday. The reason for this is that material, you'll notice in green here, the colors indicate what's fair game for which exam. So this material in green is fair game for the exam 1 on Friday. And that means that in order to prepare for that exam, the purpose of the homework being, after all, to help you learn the material, you should do these exercises as part of your preparations for this Friday exam. And to make sure that students do that, I'm having it due on Friday. Again, now with the idea of office hours, and I want students to have an opportunity to do office hours. I don't want students to find themselves attending a lecture and then having no opportunity to go to office hours to speak of and then be tested on it. You'll notice that Wednesday's material is not included that week because Wednesday learning material Friday test. Again, I think it's just too fast of a turnaround. But so for this homework assignment, it's the Monday material. You'll see that it's the last day for that homework set due on Friday. Okay. Then I also have last, I guess, thing I'll point out. There's a column section, you might say, over here on the right of comments and reminders on certain dates. I think it's worth making certain observations. So, for example, looking at let's see here, this one right here on this date, which is Friday, January 26th. I think it's worth noting that there is an exam in just 2 weeks, right? So I put this comment here. There's an exam in just 2 weeks. That's just as a reminder, just to help you keep up with what you should be doing. And one of the things you're going to read when you read the website in hopefully in the next couple of days is that I strongly advise that students prepare for exams continually throughout the semester. Don't think of exam studying as something you do 2 or 3 days in advance. That's a big mistake. There's too much material. It's not realistic. It's you will find that to be a very ineffective strategy. It might have worked in high school. It might have worked in let's say a single variable calculus class that where you'd already had single variable before, and it's kind of review mostly. In a class like this, where there's so much material and it's basically not review for hardly any students, studying just a couple days in advance of the exam is not an effective strategy. So I think you should come to every lecture in this class as if there is going to be an exam that day, fully prepared to take a test that day, every day. That way, a couple of advantages. First of all, you won't have to cram short-term memory. The idea is right before the exam. And you'll get your learning into more of a long-term memory instead of a short-term memory is part of it. Secondly, that additional understanding that you have early on will then allow you to have an easier time learning the later material. So, in fact, studying early will add up to less total effort on your part in learning the material because you'll be learning the material in order effectively. So I think it's a really big point. Anyway, so this warning on Friday, for Friday, January 26th, this warning that there's an exam in just 2 weeks. If you have perhaps not been able to live up to the goal of coming to every lecture as if there's an exam that day, this is a warning that the exam is in a mere 2 weeks, and that's a very short amount of time to learn a very large amount of material. So again, just a quick warning there. So various such reminders and comments and suggestions throughout the term, and you'll find those in this column right here. Okay, let's see here. So again, colors. This are the way I'm organizing on here what fair game material is for any given exam. So green is for exam 1, yellow for exam 2, blue, light blue, I guess that is, for exam 3. There is this little weird thing down here. This material on the Monday, right before the exam on Wednesday, last day of class, it doesn't fit very well in the homework plan. I don't think it's reasonable to have it due a mere 2 days later, previously discussed. And I believe the rules disallow me from having homework due after the last day of class. So it's just not set up for me to be able to have that submitted. Nevertheless, again, with the colors, note the orange, whatever's in this cell here, that orange, that is, per this orange here, fair game material for the final exam. So I still strongly advise that you do those homework exercises. You just won't submit those exercises. Okay, so that's the lecture schedule. Class schedule, we're calling it. Okay, so back to here. Let's see here, moving along. Let's talk about class grades. So again, going to the website, here we are. And now you see where it says class grades right there, and we will get to that momentarily. I am, though, first going to go to course website and note that there's a section called course grades. So all of these discussions here apply to all sections of the course. And so all sections of the course are going to use a highly comparable grading system. This is to ensure fairness to all students. So in particular, everything's going to be by way of grades on the 4-point scale. So y'all are aware of this, I'm sure, that 4.0 is an A, 3.0 is a B. There is also a B plus, 3.3, right? Things like that. So that's how we're going to do all grade arithmetic in this course. Now, when you take a test, of course, it's going to be maybe 0 to 100 or something like that. Depends on the instructor, whatever. Ultimately, doesn't matter. That will get converted to grades on the 4-point scale, and only the grades on the 4-point scale will be used in course grade arithmetic. So grades are going to be by way of a weighted average. The weighted average will go by way of these weights. So again, all sections will have 60% of the course, 60% of the weight on the midterm exams. Now, different instructors might weight different exams differently. I'm going to be doing 20-20-20 for the 3 midterms. But if an instructor chooses to have 4 exams, then they might be 15-15-15-15, or something like 10-13-17-20, something like that. It's up to the instructor there, right? The final exam will be 30% for all students, and then there's an additional 10 that instructors have the flexibility to attribute however they like. We'll talk about how I'm going to be doing that momentarily. When that weighted average is computed, looking at your grades on all these graded items, weighted average using these weights, you will end up with a final weighted average for the course. And that weighted average will fall into one of these bins. So, for example, let's suppose your weighted average ends up being 3.58, let's say. Right? Well, 3.58 falls into this bin. You'll get an A- for the course. So it's a nice, simple little system. These bins, by the way, are chosen in, I think, a pretty natural way. So, for example, you'll notice this 3.15 upper bound for the B bin. Well, that is the number that is exactly halfway in between 3.0, which is the sort of the canonical B, and 3.3, which is the canonical B plus. So this is the cutoff that's sort of halfway in between these two B and B plus grades, and therefore that's the cutoff that I use to define upper bound for the B bin and lower bound for the B plus bin. And notice that this is closed on the left, which means tie goes to the student. If you get a 3.15 exactly, you round up to B plus. Okay. All right, you're going to notice that pattern continues for most of these cutoffs. One of the exceptions being up here, for example. Oh, excuse me. There's a statistical phenomenon that when you average numbers from a distribution, the distribution of the averages tends to pinch in. It tends to narrow the distribution. The standard deviation decreases, and this is most prominently noticed at the edges. I took a large amount of data and did an empirical study and ascertained from that empirical study that the way to deal with that on the high side of the extreme of grade possibilities is to lower the cutoff for an A plus to 4.05 instead of what one might have expected, 4.15. So anyway, the relic residue from a statistical phenomenon. Okay, all right. Now, a few other things. Take a look. If you're thinking about taking this course, SU, make sure to read this discussion. A few other notes about course grades you'll want to make sure to look at. Now we're going to go back, though, to the class website and look at where it says class grades right here. Here are the further details. And first thing you're going to notice are the weights down here. So as I discussed, we're going to do 20% for each of the midterms. Final exam is 30 as required for all sections. And then here's how I'm going to break down my flex 10%. 7% will be your homework average. 3% will be attendance. So do notice, and this is an important observation, attendance counts. And a lot of you might look at this and think, well, 3%, it's not that big a deal. But if you have poor attendance, averaging in a 0 for 3% of your grade can make a pretty significant difference, right? 3% reduction that you would expect to be somewhere in the range of 0.1 or so, depending on where you're at in the grade scale. It could make as much of a difference as 0.12 or so, 0.13, I guess. It's a very high side in your average. And 0.12 or 0.13 is a lot of. That could make a tremendous difference in your course average. So please do make a point of taking attendance seriously. We'll talk more about that later on. Okay, so exactly how I'm going to compute homework average and attendance scores is discussed in great detail down here. A very explicit formula. Do make sure to read that. Note also the 4 examples. You want to make sure you have a clear understanding. A lot of students figure again that it's not that big a deal. But notice in this example down here, a student, if let's see here, if there are 31 lecture days where attendance is counted, I don't start counting attendance until at least a week into the class. It depends on various things, but when the class roster is in flux, it's a weird thing. So if there are 31 lecture days where attendance is counted, and if you have 1 excused absence and 3 unexcused absences, then what that means is that of the relevant 30 days, we're there for 90%. And now 90%, that sounds good, but you got to keep in mind, let's see here, 65% is a 0, right? So because students should be attending class, showing up, a mere 2/3 of the time is not good. This is not an acceptable amount of attendance. So anyway, point is that 90% translates to an attendance grade which is only about a B or B minus. So 3 unexcused absences, again, it doesn't sound like much, but that takes your attendance grade down significantly. So make sure to be aware of that and make sure to come to class. Again, that's what we're here for. Okay. All right. So let's see here. Going back to the organizational notes, let's talk about the YouTube recordings a little bit. So I am a huge believer in this idea of recording classroom presentations. I think this is a wonderful way to learn. I certainly know when I was in college, I did not understand every single thing that my professors said in class as they said it. That's not realistic. That's not how it works. That's not the human experience. So I always wished, as I was studying after class, that, okay, well, now that I think I've studied up and I think I understand this material a little bit better now, but what was that thing that he said that, I didn't get it at the time, but that sounded important. What was it? Well, of course, this was decades ago. This is before it was so easy to make recordings, and so I had none. There were no recordings of my lectures, and so I just didn't get to benefit from those comments that I missed in class, unavoidably, no fault of my own. right? So I think that's very unfortunate, but that was the nature of the world at the time. Nowadays, it's so easy for me to make these recordings, and I encourage you to make heavy use of these recordings. So any time that you don't understand something that happens in class, just make a note. And you can come back and watch it again later after you've had a chance to firm up your prerequisites, solidify your understanding of the surrounding material. You go back and listen to that thing that confused you in class. You listen to it later. Well, it's going to make more sense. It might make perfect sense. And this is a really valuable idea. Now, I have a favorite logistical, life hack tool for how to keep track of this sort of thing, and that is to just make annotations about time when there is a point that you want to review later. And so this is really easy to do. Let me go over here to my lecture notes. This, by the way, is what it's going to look like when you come to class. This is what's going to be up on the projector screen, and I will talk about whatever is going on in the material, and I'll talk about the triangle inequality. Let's get into this mode. We'll talk about the triangle inequality, and I might draw some stuff over here, and this is just kind of how lecture is going to work. And then as we go along, and as we get to, I like to point out as a possibility, this example right here. Well, this example is actually a bit confusing. There's some tricky ideas in this example. There's some subtleties in this example. And it very well might confuse you when we talk about this in class. So when we do, if that were to happen, if you were to find that, in class when we talk about, if you just don't feel like you got what I meant, or want to see it again later, and want to make sure that you ensure that you will see it again later, you just come down here, look down here at the clock, and you see it says 12:30. Well, let's say 12:31. I just make a note on your copy of the note. Whoops, I was in a weird mode. It looks like. Let me get rid of that. Let's see here. You just write down 12:31, and you could even write down the date. Jan 8. Just jot that down real quick. And then when you want to come back and listen to that again, after you've had some time to chew on it and think about it, maybe come to office hours, maybe ask a friend, maybe read the book a little bit. When you feel like you're prepared to take a second whack at this example, you just fire up this recording, click forward to where you get to in the recording. This little clock will be visible, and just click forward to where you get to 12:31. And listen to it again. It's very, very easy. And again, making these annotations, I think, is a nice trick for how to be able to do that. Now, I am going to take this moment to pause. My stylus on this laptop computer does not work as well as I wish it would. The battery is not that great, so I'm going to switch over to my other pen now, and hopefully now I'm back in business. There we go. Okay. All right. So anyway, good hack. I hope you will take advantage of it. Okay. All right. Back to, the organizational notes here. So let's talk about the learning goals for the course. This is a very important thing to make sure that we have straight before we proceed into the course. A lot of students misunderstand what a math course is, what a math course is fundamentally about, what's important in a math course, what are we going to be tested on, what are we really doing here? So hugely important and appropriately built up as such. Ideas and reasoning. That's what this course is about. It's a course about ideas and reasoning. I will point out further, I think this is actually pretty typical. I think this is the case of most classes on campus, maybe not quite all, in different departments, of course, adapted appropriate to the nature of the field. But ideas and reasoning is very broadly in many, if not most, departments what the course is about. So now, common misunderstanding, a lot of students have taken high school math classes or lower level math classes where, maybe realistically it's just, it tends to be, well, if you get the right answer, okay, well, whatever. But very importantly in this class, not so. Right answer does not mean happy grader. We are looking for valid reasoning using important ideas. And we want to be able to see that. I want to see your reasoning. I need to understand your reasoning. I'm not just going to look at the answer at the bottom of the page and see if you got the right answer. I'm not just going to look and see if you, applied the right formula. I want to know what was the reasoning that led you to use that formula. Things like this. So anyway, make sure to be clear on this. This is you're going to notice this very heavily reflected in the lectures for this course, and that'll be very evident very early on. That I'll spend a lot of time talking about ideas and reasoning. What I don't want you to be surprised about is that this is also going to figure prominently on the exams, right? So you need to be prepared as you're studying the material for this course that the exam is not going to be just here, crank out some answers, plug into some formulas. The exams are going to be an attempt to understand, to get into your head and see how much do you understand the relevant ideas and how effectively and appropriately can you apply appropriate mathematical reasoning to solve problems. Okay, so now this being the case, make sure you keep all of this in mind. You can't have a formulaic approach to the course and then just shift instantly onto the exams. In all of your learning of the course, you should be focused on ideas and reasoning. As you work on homework assignments, etc., you should be focused on ideas and reasoning, right? So that when you get to the exams, you will be rehearsed and practiced and polished in communicating ideas and reasoning. Okay. So just to be as explicit as possible on exams, here's where points come from. It comes from the validity of your reasoning, the completeness of your reasoning. Did you think everything through? You didn't skip any big steps or forget to check any important conditions or of a theorem or anything like that. So again, heavy focus on reasoning. Clarity of thought. Now this is a subtle one. Clarity of thought is actually really important. And this shows up in a couple of different ways. So, did you solve the problem directly, or does your solution involve a bunch of meandering around pointlessly? And why does this matter? Well, because meandering pointlessly, even if you get to the correct answer, again, I emphasize, we're not interested in answers. Even if you get to the correct answer, it shows that you don't have as good of an understanding of the ideas. When you have a really strong understanding of ideas, you just go right to the correct solution. Right? So anyway, keep that in mind, right? Related note: if there is an easy way to solve the problem using a important idea from the course, and if you solve the problem by way of a much less efficient brute force idea, something like that, that is not that. Again, that's a lack of clarity of thought. That's a lack of real understanding with the important ideas. And so again, it's not about answers. Even if your inefficient solution gets to the right answer, right? Again, don't care. It's not what the course is about. The point is that you have a student who has such a solution does not have as good of an understanding of the ideas, right? So do keep in mind how important For grading purposes, it is to demonstrate your understanding of the relevant ideas. And don't make this mistake. As much as I know it's drilled into students in high school, it's really, really wrong. Don't make the mistake of focusing on answers. Okay. And then lastly, clarity of written communication. Again, if you understand ideas really efficiently, really powerfully, really deeply, then you can write about them. Conversely, if you have trouble writing about the ideas, that is an indication that maybe you don't understand those ideas as well as you think you do. And it'd be a good idea to solidify that understanding so that you can write your ideas clearly. Okay, so that's my soapbox speech on that. Let's see here, last bullet point, or last major heading anyway, learning strategy for the course. Let me again go back to the class website and specifically to the course website. Notice, I guess while I'm here, I should point out the course design and strategy. And so it's important to understand how this course is set up. What is my strategy for how to help y'all learn the material? And there's an important subtlety here that you need to understand. It is not right to think that that the way that that I will set up my lectures so that you will learn as much as possible in class. It's just not quite true. It's close. It's not quite true. I will set up my lectures to help you learn as much as possible in the course. I don't expect that you will learn the material entirely in class. It's just not possible to learn all of the material in class. There's just too much material. There's not enough time. It's not possible, right? So if I set up my lectures to try to optimize student understanding at the end minus student understanding at the beginning, well, that's just very narrow. That's not where student learning is happening. Student learning is happening outside of class also, arguably mostly outside of class, through watching the recordings, reading the lecture notes, reading the book, talking with study partners, going to office hours. There's so many different places where I'm expecting that y'all will learn, right? So anyway, it's very, very important to understand that this is the strategy. This is the expectation. So for example, as I'm designing my lectures, I am assuming that you're doing all the other things for the course that you're supposed to be. Right? So very, very important, and make sure then that you come to class having already looked at the material. This is going to be assumed. I expect that you will have flipped through the notes or read the appropriate section of the book, something along those lines. Obviously, I don't expect that you will understand it all. That would make me unnecessary. That's obviously not right. But I do expect you to kind of flip through and have a kind of a rough idea, have some questions formed in your mind about, hey, how did that part, I didn't understand that part of the notes. That seems like a magic trick. What allows him to just do that? That doesn't seem fair. Have curiosity and questions already formed when you come to class. And then, of course, you come to class. Hopefully I answer as many of those questions as possible. Oh, gosh, here we go. Hopefully I can answer as many of those questions as possible during the class meetings. And, sadly, I have to make some tough choices. This is very unfortunate. This is the nature of teaching a course that has so much material in it. But I have to pick and choose what I spend time talking about in class. There's just not enough of it. And so I'm going to talk about key ideas that are the most, various different considerations. Yes, importance to the course, but also things that I can help with live, right? There's some things that are really important to the course, but you just have to do on your own. Practice, for example, polishing your skills and proficiency with techniques. You have to do that on your own. Right? So anyway, I'm going to make these tough choices in class, and again, with the goal being to give you the maximum possible learning benefit in the course overall, and not so that you will learn as much as possible in that 50 minutes specifically, which is just too narrow. Again, I'm also going to be assuming, as I design these lectures, that you'll be reviewing extensively after class. It should be a tremendous amount of study time. After the class, studying on your own, studying in a group, reading the book, reading the notes, watching the lectures, going to office hours, all of that kind of stuff, right? And I design my lectures with that assumption in mind. So keep in mind then, because I am expecting and assuming that you will be doing all of these things, these are all linked together. And if you remove one of these, if you, for example, don't preview the material before class, then not only will you lose the benefits of that preview, but you will also get less out of class itself. Right? So anyway, keep that in mind. It's all very important. And let's see here. Then I also want to point out this page called Learning Expectations. There's some discussion here about all calculus courses, block calculus courses in the math department. Students should expect to achieve all of these goals, broadly speaking. Again, another reminder. This is a course about ideas and reasoning, right? Very important. And then I've got some various other discussions here just to elaborate as much as possible on what do we mean by this and why. And I think there's some really good, really important points in here, and I want to make sure that you take the time to read all of this and understand, what these learning expectations are and why, so that you can get the most possible out of the course. Okay. Alrighty. So let's see. Whoops, that's the wrong screen. Whoopsie. Here we go. Oh, there we go. Okay. All right. So I think this. I think we've covered most of this before come to lecture and then after class. Okay, a couple quick bullet points I want to hit before we wrap this up. These are just hopefully useful ideas. I'm a big believer in this one right here. Maintain a list of questions. When I was in college, I just had a piece of paper that I carried around because it was the early 90s. And I didn't have a smartphone or a laptop. They didn't exist. So I'm sure you can have a much more high-tech solution here, but you want to have a list of questions, things that you have identified that you don't understand. And then cross it out when you do understand it. And this way you won't lose track of things that you need to follow up on. So again, just a little life hack for being a college student. I hope you find that useful. Make sure you're aware of all the course resources. This is a section on the course website. Lecture notes, all of my old midterm exams with solutions, with and without solutions, that is, all right there, available for you to use. Knock yourself out. The help room for the course, very useful tool. The Academic Resource Center has some very nice resources that I think that you should make sure to at least investigate what they have. They have some nice tools. Varies from term to term. And, of course, don't forget about office hours. Now, you're very welcome in my office hours. I do want to point out we're going to be sharing office hours this semester. So not only are you welcome to my office hours, you're also welcome to the other instructors' office hours. And I'll go ahead and point out on the website. Let's see if we go back to this is the course website, right, for all sections. Notice there is a page down here called Office Hours. And I already have my office hours listed, and the location moves around, you'll notice, depending on where I am, on at what time, on what day. just because I'm aware my lecture schedule is a little bit weird this semester. But anyway, very soon I will have office hour listings entered here for the other instructors, and this will all get edited as well. And then a couple of quick notes here about general office hours policies. Okay, all right. So you're welcome at all of these all of these office hours, even the other instructors, and likewise their students are welcome to mine. Okay, all righty. And then let's see here. We're probably getting real close to being done here. For whatever it's worth, I'm a big believer in study groups. I learned a tremendous amount of math and physics. I did both when I was in college, and I learned so much, especially the physics, frankly, from my classmates. And so I think having a study group is just off the charts valuable, super, super important. If you already have some friends in the class, great, cool, excellent. You got a study group. If you don't, or if you don't want to study with those friends, whatever the case may be, I would encourage you to exert some efforts to create a study group. And frankly, the Academic Resource Center is a pretty good resource for this. They have something called the Study Connect program. Study Connect is a very clever, efficient little system that they have to allow them to pair up or group up students who are interested in finding study partners. So I encourage you to sign up for that if you don't already have a study group, or if you just want to increase the number of students you can study with. Okay, and then the last thing, I've already kind of hit this point, but when you're doing the homework, think of that as practice for writing on the exams. Again, it's not about the answers. It's about what we can determine that you understand about the ideas, and what we can infer about your ability to perform appropriate mathematical reasoning from what is written on the page. And writing your ideas and being able to represent all of your understanding in writing is tricky. It takes practice. And doing the homework as if you were taking an exam. In other words, as using it as practice for the exams will help you be better at that. It will help you do better on the exams. So please take that approach. Don't try to don't try to save pencil lead on the homeworks. You want to practice good writing and communication. And one last thing, I guess I should sort of correct myself on that last point. I said pencil lead. I should have said ink. On the exams, we'll talk about this later, but I do require black ink on the exams. It's just a logistical thing. Pencil doesn't scan well with the scanner that I can't avoid using. And so I encourage you to use black ink on your homework as practice, for how the exams are going to run. Okay, all right, so I think we've made it to the end here. I am looking forward to going through this semester with y'all in Math 219. It's a wonderful course. The material has a lot of really beautiful aspects to it, and I hope you'll enjoy the course as well. And see you on Wednesday. Okay, y'all have a good 48 hours before classes start.